Assalamu alaikum all. Thank you for joining us again for almost weekly webinar now. Today we have engineer Karim Zulfiqar joining us to talk about some innovative solutions in building design. Karim is a NED graduate and he is a structural engineer. Got his master's in structural engineer from UET Austin. He has more than 23 years experience and keeps saying that he's old, and I think he's very young. Most of his experience is in the multiple discipline of engineering services, including design. And I think based on what I have seen, the building designs that he has done, I think they are extraordinary. And I can say that very easily because these are really very different design than I usually see in USA. Thank you, Karim. Really appreciate कि आपने NED scholars का invitation accept किया. It is an honor for us to have guys like you to share your experience with the young engineers. We have at least 3 engineers right now online. Usually these engineers sit down in one room and try to have a group joining us in one setting. So as Rais is saying that there are other people who are doing namaz right now, they will going to join him. So I will now leave it up to you to proceed. And as I was explaining before to you, I have to leave in 10-15 minutes, but Dr. Asma will be with you all the way. Thank you again. I really appreciate, Karim, for you taking the time out from your busy life and specifically on a Sunday to share your experience with us. Really appreciate it. Thank you.
Thank you very much. Assalamu alaikum, everybody. Today's topic, I think I wanted to present this project case study. It's not technical. It's just making sure that as an engineer, when we are designing or when we are pursuing project, we are not stick to our typical traditional thinking. So the idea is, and I'm hoping that by the end of this presentation, we'll start thinking what are the other options, what are the other ways to do something that we typically don't think about it. So this project started back in 2014, 2015. It's for Abilene Christian University. They have an old campus there, and let me switch to my next slide. So this is an existing campus. Abilene is a town about 2-hour drive or 15-20 minutes flight from Dallas on the west side. A small town. They have this campus since 1930s. And we were tasked to modernize one of their existing buildings and also build a new engineering facilities. And there are some of the donors that were very interested in donating for this campus because of their past history with the campus, and also some of the donors actually were alumni of this campus. So right now, if you can see on my screen and my cursor, this is one of the buildings that was built in pieces. So the center core was built in 1930s with the conventional construction with a basement. And then the 2 side wings that you can see, these were built in 1960s with post-tension slab. So not only you have almost 80-year-old building in the center, and then you have a 60-something-year-old building on the side. Some has basement, some doesn't have basement. One of the things, of course, Google updates their map. One of the things they don't show here is there used to be an auditorium, which was also an old auditorium that got demolished during construction. So this picture actually was taken as they were starting to demo and clear the site. So one of the modernization projects was making this existing building become part of the new construction and building a new engineering building on the on the left side. So this is the owner is Abilene Christian University. This is a design build project, and those who are not aware of this, usually there are different type of delivery methods used here. Design build means the owner will select a contractor, and the contractor is responsible for everything. A contractor selects the design team, architect, engineers, and everybody. So we as an engineer work for the contractor. There are other delivery method like the typical contractor is hired separately and the design team is hired separately by the owner, and there are others, but without getting into too much detail, this was a design build project. So when you have a design build project, the major challenge is always design builder is your client. So you are making sure that the project stays under budget and the project stays on schedule. So if you have an old building and of course there's a new building, there's a reserve amount that the owner is going to pay for it. And the design builders bid on that, and they assure the owner that they will do it. So that was the first challenge, to making sure that whatever we do, we are not creating something that's going to cost a whole lot and it's going to delay the schedule. So this was the vision that started as the modernization of the building, which you see where my cursor is on the left side, and also this is the new building. So when we looked at that rendering, it seemed like, yes, doable. The major issue was that how you take a building that's 80-something year old without demoing it and make it work for the 21st century. The other challenge was there were multiple donors. The donor for this building, a lady, now she's probably in her early 90s. She was in her late 80s when she donated, and she wanted to have that built because she was worried that she'll pass away without seeing the building completed. So that was an extra layer to make sure that we stay on schedule to complete that building so she can inaugurate this building. This is another rendering that got a little bit simplified. You can see this is the building right here. One of the major challenges was, of course, the landscaping, because there are multiple feet of difference from the ground to getting up to the first floor. So when we saw that one, just the exterior rendering, it was something that we wanted to do. It was an exciting project. Till we saw the interior rendering. The idea for the new building was to create a floating structure, because this is a science building. And these days, we have a couple of other major projects in the office where we are working with campuses. They want to create state-of-art facilities for whether it's engineering or science and technology. So what they want to show, of course, and as an engineer, we want to show is something different. So if you see something like this, the first thought is how you're going to support it. And that's the traditional thinking, right? We always want our columns to be supported from ground, and we want to have the framing. The other challenges are, and I'll show you a simplified rendering also, but the challenges are you have a corridor on the exterior, and you have the public space in the center where a student can gather. So major issues are not only strength and deflection, but also vibration. You don't want the kids running around the corridor in the exterior, and interior spaces where people are trying to concentrate are getting disturbed by the vibration. So you have to make sure that not only you can support this structure, you can support all the loads, but at the same time the structure is stiff enough to provide that that vibration resistance that you need. So this was the simplified version. Still, the idea was you don't see any columns here. This is a floating structure. You don't see any columns, and then these side wings were traditional construction. Even though we had columns on the exterior, they didn't want it to connect to the exterior so that it looks like it's floating in the middle. And you can see even within the ceiling, it was a separate structure. So we were looking at options that what we can do differently that can support that and provide the stiffness that we need. In this picture, you can see the exterior still has the corridor, public spaces. People can gather on both floors, and inside the spaces are the auditoriums where you have major classes going on, presentation and all that. So same concept, keeping the structure stiff enough to minimize the vibration. So when we saw this rendering, our first thought came into mind is like exterior, they wanted to have a very thin construction. But the interior, we see a little bit more mass where we can have heavy structure within that ceiling space. So that was that actually was the basis of our design. What we can do to capture that thicker section within the ceiling space and support this structure. So one thing that I just pulled this one this morning, and I was just looking at that how many graduates each country has, and you can, of course, this probably is not surprising for you that China and India produces the most student in science, technology, and engineering. But when you have these millions of students, graduates available, and thousands of engineers throughout the world graduate from different universities, as an engineer, how you are going to distinguish yourself as a different engineer, because everybody can go and hire an engineer from anywhere in the world. So the idea is that we have to come up with something that differentiate ourselves from others. And same thing is that keep in mind that whenever we say innovation, innovation doesn't necessarily mean added cost, more time. Innovation means thinking differently. So here the challenge was what we can do. And one of my coworkers, she worked with me, and I just pulled that. This was my 5 minutes laugh on a project. But you can see that this was a picture available on the internet. So I said, oh, looks like we can do something like this. We can do a floating structure. But if you look at the structure itself, it's pretty standard. It's pretty traditional structure. You have a roof framing, you have columns, and you have the steel braces, which you can see here. The only difference is the different levels of roofing, and you see this pop-up was part of the design. This area was the skylight, and this is where we saw the opportunity of adding a thicker section in the ceiling. So this is a typical floor, and this piece right here where my cursor is, this is the floating part. So there is no connection to the exterior column. These are the exterior columns. And then this is the traditional building. So one of the things that we wanted to make sure is that, of course, there was one-sided connection, and we have a very small corridor connecting this floating part with the rest of the structure. So we wanted to make sure that it's stiff enough to take the load, but what we do, we cannot do major cantilever from the back span because we don't have enough width on the exterior. So what we did is we tried to frame this one as much as possible using the traditional method. Again, remember this was a design build project, so we were working for the contractor. We were trying to make sure that anything that's easy for the contractor to construct and within the budget. So that was the challenge. So we tried to do all this staying within this space. But then what we did is we said, okay, we saw the rendering and we have some opportunity to add some vertical hangers. So we picked some location where we saw some opportunity outside of the glass facade, and we added some hangers. a very simple design. The only thing was making sure that there is a compatibility when you have columns that's ground supported. Throughout the building, columns are ground supported, and now you have members that's ceiling supported. When you release those columns, there are going to be differential deflections between the two. One will transfer the load directly to the ground, one will take the load to the ceiling and then transfer to the ground. So I wanted to make sure that we take that into account. So one of the things we did is the sequencing was important. So we worked with the design team, we work with the contractor, and making sure that we sequence these in a way that all these areas were shored. Even when they had the hangers in, all the roof, everything was done before those shoring was released slowly, and we measure every time they remove the shoring to make sure that these hangers are deflecting to an amount that was our basis of design. And this is the roof level where you can see that we did like framing was going in all different directions. The reason for that was we were trying to put a hanger in a curvature, and we had to allow the framing to line up wherever we could find location for the hangers. And this is the exterior of the building. So this line represents the exterior. This inside is the part of the building. This is the exterior cantilever. So not only we had the challenge of hanging the part in the center, but also we had pretty decent cantilevers. Some were about 20 feet or so, and staying with a very thin profile outside. So what we did is we decided, what if we take these exterior columns, which is supporting the glass, we have the opportunity to frame, not at the floor level, but we can frame that at the roof level. So this is our roof plan. We took the interior columns, we took the exterior columns, and we added a bunch of transfer girders. And then we started hanging the hangers from these transfer girders. And then one thing we did was, once we touched the exterior column, we start tapering the members to a very thin profile that can cantilever all the way out. So in terms of designing, I think one thing that I would always tell younger engineer working with me is that if you want to differentiate from other structural engineers, one thing you never want to do is start with simplifying the solution. Take the challenge that you see and then try to find ways to simplify it without compromising on the design or adding the cost, because there's a whole lot of engineers in everywhere. Even in Houston, where I'm here, we have so many competition in the field that people can easily take the project, they can put a grid, and they can frame steel or concrete, whatever they want to do. Can you please mute whoever is So the idea is that you can use the columns and you can try to take the approach that the designer is envisioning. You take the cost and try to find a solution that fits within that, and then work backward and try to compromise if you think that project is over budget or the cost is significant, that you have to simplify it. So very simple structure. Again, we didn't use cable structure. We didn't use anything that's require extraordinary cost. Anything that was not available. Steel members and concrete and steel hangers. That's all we used. So this is what it looks like, and this is during construction. And you can see that these were the steel members that were going all in different directions. These were about W30 members, And then you can see these are our hangars. Very thin profile for the hangars. Columns were again 24 or something, W12 or W14s. These hangars were 8 inches in most cases, but we tried to stay with 6 or 8 inches combination, wherever we were able to fit behind the solid wall so nobody can see it. And you can see that framing right here, all this is kind of a combination of cantilevers, outriggers. We tried to frame as thin members as possible. And then at the same time, about 20-25 feet of cantilevers outside the building with a very thin profile. And when we designed it, even the steel fabricator was worried that these will deflect while they are installing the steel. So you can see that they added these diagonal stiffeners or kickers to temporarily hold everything while they are building this structure. So this is the stage or the phase of the construction where all the bottom shorings were removed, concrete was poured, and now we have a structure. The only thing was, of course, this was not loaded for the intended occupancy. So this was the construction, during construction, and it was pretty much done. MEP is hanging their ductwork, exterior cladding started. So this is like, again, a very complicated structure, but we didn't use anything out of ordinary. Steel and concrete is all we use. Another view, you can see that this is the concrete floors. They were getting ready to put some girts around the column to support the exterior glass. These are these long cantilevers with temporary bracing. And then there is another view. And you can see that these are pretty significant cantilevers. But again, this was a pop-up roof, steel construction, nothing out of ordinary. So the building completed in 2017. This is the opening ceremony of the building. You can see that the glass facade with the columns that's supporting not only the interior of the building, but also the exterior. On the right-hand side, you can see this floating part, and you can see one hanger right here, but most of the hangers are hidden from view. Nobody can see, no columns underneath here. And you can see the reason they didn't want to have the column, because they wanted to have this gathering where hundreds of people can gather without having to deal with the columns in the way. So this was pretty much a public space. One thing that I forgot to mention in the beginning is that the site, and let me go back to the first slide. I just want to give you a perspective. This one has a basement. Part of this building has a basement. These two parts were designed without the basement. The new building construction was right here where my cursor is. This is again during demolition. The existing site has half of that was existing basement that was demoed, and half of this was on soil. So we have so many different conditions that we had to fill and make one slab which is soil supported, but taking into account a whole lot of fill. So when we go back to the slide of the opening ceremony, one of the challenges was to make sure that this exposed concrete doesn't have cracks, because everybody is walking in this space, and we didn't want it to tell them that this structure is not stiff or strong enough, and we are seeing all this cracks. So we did on our drawing, typically allowing them to saw cut slabs so that we can compensate for temperature and shrinkage cracking. So this building was opened. It's completed right now. This campus has a whole lot of international students. And this is one of their latest building. If you go to Abilene Christian website, you can do a virtual tour of the building, and the result came out really good for everybody. So I think the message that I wanted to convey through this presentation was we stayed within budget, we stayed within schedule, we didn't change the design intent. The donors were really happy because they saw what they were putting money in. They saw their vision there. So it worked out really well, and not using anything that was not available. Contractor was really happy. We were profitable. Contractor was profitable. As an entire design team, we were able to deliver this one on within cost and within the schedule. And then last year in December, we worked with Model Steel Construction, and this project was featured on the cover page of the Modern Steel Construction. And when we were writing this article, we pulled all these different images that I showed you, and you can Google it if you want to read this one. I know it's probably hard to read from the screen, but the idea was that when we talked to the Modern Steel Construction folks, the editor sent me a long list of questions. What are the things were done differently? What we can showcase in this publication that is helpful for other engineers to learn. And again, you look at the pictures, and there is nothing out of ordinary. It's just the concept of using material differently than we typically think about using it. So column doesn't always have to be ground supported. You can always find ways to find wherever you can opportunity to make sure you are trying to make a difference. With that, I think that's what I wanted to show you guys, a case study. Asma, I don't know if you can unmute anybody with questions, but that's about it for the presentation. I'm happy to answer any question you may have.
Karim, there is a question from a student.
Okay.
He wants the link to the site so that they can do a virtual tour of the building.
Okay, I'll send you that.
Okay, there is a chat box here. Can you see that?
Let me see. I can see it.
If you can write the URL there.
Okay, I will do that.
And I have, and for the benefit of the students, can you explain to them what is design build?
Okay, so what happens in the design build construct? There are multiple delivery systems. One is owner will hire an architect to design a building. Architect will hire engineers to work with them, and then we finish drawings and we submit for bidding. The different contractor will bid the document, and one contractor will get selected. That contractor works for the owner. Architect works for the owner. This is called the traditional design bid build construction, where owner is managing architect and engineers, and owner is managing the contractor. What happened in that condition is that when there's a construction issues, everybody is pointing fingers towards each other. So these days there are 2 or 3 different delivery methods are used. One is the CMR, which is the construction manager at risk. So during design, same thing, owner will hire an architect and then another contractor, but the contractor takes the risk. If the cost is more or they are delayed, they are at risk. So they manages the owner and the architect, but still the contractor is working directly for the owner, the architect is working directly for the owner. So again, same thing, finger pointing. What design build does, and this is one of the areas where we are seeing a whole lot of growth, is that owner says, oh, I have $10 million or $100 million. I want this building, I want this function, I will hire a contractor. Mr. Contractor, you're responsible for everything. And that's where the design builder will take responsibility of managing the architect, engineers, contractor, everybody on the project. So the owner is only dealing with one entity. So that simplifies a lot for the owner, and also at the same time, it's less issues in the field, less lawsuits, because you only are dealing with one entity instead of multiple. That answers your question?
Any questions? You can mute yourself, or I'll unmute you if I muted you from here. Write in the chat box so that I can see. Someone has a question, but I don't know who is that person. Do you mind writing in the chat box, please?
I don't see the chat box, anything popped up.
Yeah, me either. So I think the students have thoroughly enjoyed your presentation, and they're aware of all the terminologies that you used. Anything else? No, I don't see any. Okay, Karim. Thank you very much for your time. And
thank you very much.
Can you share your email address as well, so that if they have any questions, they can contact you directly?
Okay, let me write down my personal email address, if you can see on the chat box. And I will, if you can email me, I'll send you a link to the virtual tour. So once I get off from this presentation, I'll forward you the link.
Sure. So that's Karim's email address. If you have any questions, not only regarding the structural design of the building, but also, like, the higher education and what is the status of the colleges over there in Texas and the U.S. and employment opportunities, etc. So, okay, Karim, the next question is, which software is used for structural design nowadays?
So we use CSI software, which is SAP, ETABS, and SAFE. But for this one, we use SAP to do the structural design.
And Karim, there is one thing, that there is a difference in the material used for building design or for building construction in the U.S. versus the material used in Pakistan.
Right. So I think, go ahead, sorry.
No. So I think for this building, it was the concrete was used for foundation, and then the steel structure, rest of the structure was steel.
So this one is what we call it a composite construction, the steel deck and concrete on top. Pakistan, we use concrete everywhere. Steel is expensive. In U.S., steel saves a lot of time during construction because labor is expensive here. So every project we do two different systems, or 2 or 3 different systems, depends on what we see the opportunity. So we always give that opportunity to the contractor to price it. Even if the contractor is not selected, they can the owner can hire a cost estimator, and they will do a cost comparison for different systems, and then we go from there, which makes the most sense in terms of cost and schedule. So this is a steel composite system. Pakistan is mostly just a concrete construction.
Okay. There is a question, Karim, from a student, and she's asking that, can you tell the difference between different type of cantilever used in the structural buildings, or maybe in this building, the different type of cantilevers?
The cantilevers were all the same. Let me pull the image right here. You can see that these are where this is the building line. All these cantilevers outside are all white flange, W10, W12, W16. For the pod area right here, we use, even in the backup, we use W24, W27, but we start tapering those members, because what you need is the maximum depth you need at the support for a cantilever. Once at the tip, you don't have much force there, so you can always taper those members. Same thing with the roof construction. We try to have as much material in the back end and then start tapering off at the end. So to get that thin profile at the end. So everything is white flange. The color difference you see in U.S., especially in some areas where we see issues with corrosion, we try to galvanize the steel, so that's why you see this silver color on the steel. But these are all white flanges. These are galvanized interior space, because these are in the air-conditioned space. We don't need to galvanize. So, but in terms of different cantilever, everything was white flange section.
Okay, the next question is, what are the difficulties an engineer can face during design, build, delivery system?
Very interesting question. And my first project as a design that I did as a design build project was back in 2002. That tells you how old I am. But the 2002 design build project, because you are working for the contractor. Typically, we tell the contractor what to do on projects. When you are working on a design build project, the contractor is telling you what to do, and you have to find a balance. When we do the design build project, it's really important to select the right design builder. You don't want to work with someone with a reputation that they will cut corners, because at the end of the day, you are the one signing and sealing the drawing. And one of the responsibility as a registered structural engineer is the life safety. You don't want to jeopardize that. You don't want to give something where you have vibration issues, deflection issues, serviceability, because you are the one, not only you can get sued for damages, but at the same time, you are trying all these innovative ideas, and now your reputation is on the line. So you want to make sure that you find a contractor that's the right design builder. So we get a lot of requests to team up with design builders on multiple projects. Like for this one, there were multiple design builders who were chasing this project, but we partnered with one where we thought that matches with where we find the values, and that's the right contractor for the project. So very interesting question. It's just a matter of, this design build is we are working for the contractor, not the owner, but at the same time, make sure that you find the balance between bringing the project within cost, schedule, at the same time, making sure that you meet your obligation as an engineer.
Thank you. More questions? Any terminology that you need explanation for? There was one word that you kept repeating, was rendering or something like that, right? I'm sorry if I did not, I don't have the correct word, but vocabulary, but.
You mean the initial one, or which one?
Yeah, go to the slab, the one where you are showing all the structural elements.
Okay, this one?
No, go back. Further. It was a plan, it was your drawing, it was your plan, rendering.
Oh, okay. One of these?
Yeah.
Okay.
So what was it rendering or retrofitting? What was the one?
No, this is the new construction. One is the renovation part. There were two buildings that we did at the same campus. One was the renovation of this one. I didn't touch a whole lot on this one. This one, of course, most of the presentation was on this building, but part of this project was renovating this existing building. And since we have a few minutes, I just briefly tell you that, like, the challenge on this building was, of course, we tried to minimize as much as possible. We created this 3-story open space for this exterior existing building, which was in 1930s. Everything inside was gutted, and we created the spaces. We found wherever we, with some of the structural analysis, we were able to get additional capacity to support the new load. The major challenge that for this renovation part was, you can see this exterior cladding, it doesn't match with any of these old buildings. These were stones, very thin stones that were specially bought there from Italy, and the connection of the stone was a challenge because we have a post-tension slab system with all the tendons where we wanted to attach the angle to support the stone. So we had to scan every single inch of this exterior and find places where we were able to drill holes to support an angle so that we can support this stone. So all this stone cladding was the major issues. Exterior glass, of course, we added some steel, but the challenge was, again, taking a 1930s to 1960s building, try to squeeze additional capacity by doing the analysis, and try to make sure that you can meet the requirements of the new building code.
Okay, thank you, Karim. There are two more questions, and the question one is, which standards are followed for structural design in the U.S. and Pakistan?
So in United States, usually you have the International Building Code, which gives you a big picture for the loading, and then it refers to ASCE document, which is the American Society of Civil Engineers. You can find all the new loads, wind load, gravity load, seismic, snow, all the loading information. So International Building Code, right now, different jurisdiction uses different version. Then if you are, say, in Abilene, Abilene has a city, so city of Abilene has their own code, which in most cases is exactly same as the International Building Code. But some large cities like Houston, where I am, they will do their own amendment. They want to change some of the language to fit the environment for the local conditions. So, International Building Code covers the big picture. ASC, right now we are, ASC 7 is the document. ASC 710 and ASC 712 is a 2012 document. Those give you the loading. And then each jurisdiction has their own standard. Some university also have their own guidelines. So you can get, in one project, you are dealing with multiple building codes, multiple standards. Pakistan, it's been a long time, but I think, Asma, you may be aware of that, what standards are used. But it used to be a combination of American standard and British standard there. Because these are the building code. Then in terms of material, you are using the ACI, which is the American Concrete Institute, and AISC, American Institute of Steel Construction, as your material handbook for selecting the strength and the stiffness of the material.
Okay. This question is, recommend options for reducing environmental impacts of the building construction?
A very good question. One of the things that we try to do is using of fly ash as much as possible is a byproduct of the steel construction. So fly ash is used a lot these days in terms of structure. Selecting a steel, we put the requirement that the steel is available from a certain distance, so you are not bringing steel far from in the other part of the country, so the transportation cost and impact to the environment by bringing trucks and trucks of steel from there. So locally available material, try to reuse as much as possible, and then this existing building that we renovated, instead of demolishing the building, that's also part of the sustainability, because you are reusing the building, so you calculate the impact of demolition and building a new building, versus upgrading an existing building, you are saving a whole lot of carbon emission from the construction. You are saving a lot of material that will, instead of going to landfill, you are using for next 100 years.
Okay. Okay. There is one more question, Karim.
Yeah, I see that there's a how the electrical wires carry in structure. Most of the time, same construction.
Okay, sorry. Go ahead, and then there is one more question. Just see above that. It says how to adopt start design build delivery system.
Okay. So let me answer the electrical portion. It's very simple. All the cables are buried between this sandwich. It's the concrete slab and composite metal deck. So this is the composite metal deck right here. Let me go back. So this is the bottom of the deck, and this is the top of concrete. All the electrical wires are within that space. Usually the electrical wires are less than 1 inch in thickness. These slabs are about 6.5 inch total thickness, including the steel deck. So you can bury those wires within that slab. And of course, these are protected in layers, so it's not an issue with people walking on that. So to answer the question, how to adopt, if you are asking how to adopt start design build delivery system in Pakistan, I think there needs to be a discussion with the major contractors in Pakistan that if they are willing to do that, and also it takes a lot of education for the owner to make sure that when you are doing the design build project, you are giving the control to the contractor, and as an owner you don't have that control because you gave a money and you gave a program to the contractor to go and build. You cannot micromanage. A lot of owner doesn't understand. Even here in US, there's always owners that like to micromanage everything, and then always there's a tug of war between the contractor and the owner because the contractor will push back and say, no, it's not in the budget, that we cannot do, this is not what we agreed. So in terms of starting a design build project, I think we have in US, and I'm a member of the Design Build Institute of America, there needs to be a group in Pakistan, whether it's a major general contractor and major owners who typically do structural design or new building or highway construction. There needs to be a partnership, and then they can form an organization, start with a smaller group, create some guidelines, and they can always use some of the standard from American Institute, Design Build Institute, or European Design Build Institute, and see what are the things they need to understand, what are the boundaries, what are the responsibilities, and at the end, what are they trying to achieve.
There is one more question, Karim. It says, does design build indicate that construction and designing process go side by side?
In most cases, yes. Not necessary, because even the design builder is selected. They will not start construction till the design is done. But what we have done in most of the cases, even in recent days, there's always an early structure package, because what the contractor wants to do is let their subcontractors start designing steel and concrete while the architect is doing all these glass selection, interior wall, paint of the wall, and everything. So they give more time to the architect to finish the material that's not critical, but they want to go ahead and start building the structure. So sometimes we do early packages, but we want to make sure that when we do early packages, we have all the information, and at least the design intent from the architect to make sure that we are designing to the correct loads.
Sorry, I muted myself. Thank you for your time, and I think there is one more question here. Okay, no. So Hira says, okay. Thank you from the students and from NED scholars, and they have your email ID. If they have any questions, they'll contact you, and then share the website of
Sure.
the structure so that they can take a virtual tour. Thank you.
Yeah, it was a pleasure. Thank you very much.